used to rotate through my own photos, but occasionally if you one I wouldn't really want to project on the walls.
Right.
Yes. Okay. It was too hard to go like through 2,000 photos and say, no, that one. Sorry? No, I haven't. I haven't been to much of Asia actually. It's on my list of places to go. Alrighty. Okay. Hi everyone, welcome to week 7. This is officially the second half of the semester, so three cheers for that. This week we're doing a bit of a tag team lecture, at least I hope so, because I haven't actually heard from Steve Remington this week. He did assure me last week that he was coming along and going to do it for us, but Steve's actually going to do half of the lecture for me. He's going to do a guest lecture on the ETL process. Today at 11 o'clock. So I've got the first half and then Steve's got the second half, assuming he turns up. If not, I'll have to do a bit of a tap dance and tell you what I know about ETL processes. But I'm going to talk about a couple of things to do with the physical design of data warehousing, particularly the technical architectures. I've gone too far there. The technical architectures that we can use to deploy a data warehouse in an organisation. It turns out there's a few different approaches with sort of, I guess fundamentally different underlying philosophies about how data warehousing or a data warehouse integrates into an organisation. So I'll go through those sort of major technical architectures. Essentially, we're talking the difference between data warehouses and data marts. So I'll explain formally, if I haven't already done so already, what a data mart actually is, and how we might structure those architectures slightly differently. As I said, Steve's going to come in at 11 o'clock and talk about ETL processes, extract, transform, and load. Okay, so let's kick off. In fact, I reckon we might actually get through this first half of the material in about 20 minutes or so, depending on how I go. So I might talk slowly this time. It's not really my want. In fact, you're going to find I'll speed up naturally to my normal pace. Feel free to ask questions though. There's heaps of time to do so. Okay, so what I mean by the technical architecture of a data warehouse is the physical structure of the hardware and the location of the databases, the physical location of the data that resides in the data warehouse. And as I said, there's a few different ways of structuring those particular components of a data warehouse. And they represent different underlying philosophies about how a data warehouse is used in an organisation. Broadly speaking, there's two very broad options. There's the large-scale approach and the small-scale approach. And the large-scale approach is what we call an enterprise data warehouse. So an enterprise data warehouse is typically a single data warehouse that's designed for the entire organisation, hence the term enterprise data warehouse. The alternative is smaller scale data warehousing, what we call data marts. So we'll get into the different kinds of data marts, which are listed here, after we talk about enterprise data warehouses first. So I'll talk about this one first, because this is kind of the orthodox. Well, when I say orthodox, it's kind of the assumed architecture when you first learn about data warehousing. In practice, this is actually very hard to achieve for a range of reasons, which I'll talk about in a second. But the idea is that you have essentially a single integrated repository of data for the entire organisation. And it's kind of the vision, the original vision of the proponents of data warehousing in the 1990s. You build a large repository, centralise everything, integrate the data as much as possible, and then you've got this really useful resource for the organisation to use for a variety of different kinds of decision-making requirements. So the enterprise data warehouse tries to maximise that idea of integration of data, maximise the benefits that you get from integrating data and not having to reinvent the wheel every time you want to build a brand new decision support system or executive information system or BI tool. So the downside, of course, of that is that you're dealing with very often a large heterogeneous group of users. That is, a group of users, a set of users who have very widely differing requirements, because you're trying to support the entire organisation and the entire organisation's range of decision-making needs and requirements. That adds a significant degree of difficulty. It's hard enough as it is to get a set of requirements for a small homogeneous group of users, like users of a single business intelligence tool. But when you're talking about trying to identify common requirements across the entire organisation, you start to face a design issue of having to compromise on the kinds of support that you can offer the organisation. So not only is it really hard to source requirements, you're also dealing with a very complex and large project by definition. The scale of the project means that, of an enterprise data warehouse, means that you're dealing with lots and lots of different source systems, and there's complexity in that. You're dealing with lots and lots of different delivery systems, and there's complexity in that. And you're dealing with a large integrated data set. And there's complexity in that as well. So there's complexity all the way through. So large scale, complex, therefore difficult, expensive and time consuming. And one of the things that we do know from looking at case studies about data warehousing is that the successful projects tend to be those that focus on the delivery system first and foremost. That is, the main aim of the data warehousing team is to improve decision making in the organisation. And that implies that there's a very concrete set of requirements in mind when you're designing the data warehouse, rather than a generic kind of repository. The successful projects tend to have very specific decision support requirements in mind. The other thing is that with these large-scale enterprise data warehousing projects, because they're so large and complex, the warehousing team tends to get focused on data management issues, because they're the trickiest technical issues that need to be resolved. So all of a sudden we're shifting from a decision support focus to a data management focus. Sorry, that's not necessarily the case, but the tendency is to shift that focus. And when that focus shifts to data management rather than decision support, you end up with design decisions being made that don't necessarily benefit the end user and improve decision making in the organisation. To a certain extent, you can customise the warehouse to meet different sets of user requirements through customised views in the data warehouse. So essentially, you're kind of simulating the situation where you have smaller scale, more targeted data warehouses, in other words, data marts, but using logical or database views for the end users. Does everyone understand what I mean by the term a view? Was that a no? Or was that a yeah? Okay, I'll assume you know. So the big problem with these enterprise data warehousing projects that we've found is that they tend to fail because they're large, complex, and are not as closely tied to specific end-user decision-making requirements as you find with smaller, simpler projects. But it is the kind of classic model, if you like. It's the original vision of the data warehouse developers of the 1990s. So this is kind of what the technical architecture looks like. And this diagram should look familiar to you. I think I've flashed this one up, or a very similar one up, in week 1 and maybe week 2 as well. But you've got this idea of the source systems feeding data through an ETL process into an enterprise data warehouse, and that centralised repository then serves all of the data needs of the different decision support tools used throughout the organisation. But each user of each of these different tools may have very different decision-making requirements, and similarly, those requirements may evolve at different speeds and in different ways to each other. So if you've got these tools here evolving in different kinds of ways, that places all sorts of pressures on the enterprise data warehouse. And because the enterprise data warehouse is the sort of single source of, single destination for an ETL process, any changes in any of these systems here cause changes here, and we're talking about lots of systems here because it's one single data warehouse. Whereas a smaller scale data warehouse that's perhaps targeted to a smaller, more homogeneous group of users may only hit a subset of those sources instead. So there's less likelihood of change in the source systems driving change in the data warehouse. So the enterprise data warehousing approach had a hard time of it in the 1990s. It was kind of the vision, and it really didn't work very well. And there were a lot of data warehousing project failures in the 1990s, and still today. And to a certain extent, it's because of this kind of mindset of we're going to build one single repository and meet everyone's needs, and it's really hard to do that. So I'm not saying that every single project that takes an enterprise approach is going to fail. I've seen them work. but usually they work best in a more hybrid kind of approach, which I'm going to talk about later. So just be wary of any kind of approach to data warehousing that says, okay, we're going to do one big thing for the entire organisation. It's really hard to do. Okay, so I guess the main alternative to a large-scale single data warehousing repository is to have smaller scale data warehouses developed for smaller sets of users. So you identify a small group of users who perhaps use a single decision support tool, or maybe one or two decision support tools. They've got a very common set of decision-making requirements, and that means that you can tailor the design of the data warehouse to those decision-making requirements. And because the scale and scope of the warehouse is a lot smaller, it means the complexity, the project size, the project budget, the timelines and so on are a lot smaller as well, much easier to manage. And we've seen these projects work quite successfully. These are referred to as data marts because they're small-scale data warehouses. In terms of technology, they're fundamentally the same as data warehouses. You might find that you need less processing power, less size databases and hard disks and servers and so on, because the size of the problem is smaller. But you tend to find that the result of this is that sorry, I was talking about data marts. So the technology is fundamentally the same. Data mart, data warehouse, it's just the terms refer to different scales of systems. There's no clear-cut definition of when one thing becomes a data warehouse versus a data mart. You can quite happily refer to a data mart as a data warehouse if you like. The natural kind of life cycle of organisations trying to solve the kinds of problems that data warehouses solve tends to see these kinds of systems pop up throughout the organisation. So as each sort of business unit or organisational group with a sort of common set of decision-making requirements comes up against a data sourcing problem, very often they'll build a small-scale data warehouse or data mart. They may not know that it's actually a data warehouse, they may not call it a data mart, but essentially they're doing what a data warehouse would actually do. So we find that this natural natural evolution, if you like, or natural growth of these kinds of systems throughout an organisation as they try to solve their data management problems. The downside of all of this is you end up with a kind of a technical architecture that looks like this. Which, I mean, I've drawn this diagram intentionally messy to try and get the vibe across. Obviously it's not, you know, in any real life organisation there's a bit more rationality to it. But because it's an organic kind of process where each different business unit is responsible for their own data mart, there's no consistency across them necessarily. Lots of duplication of ETL processes. And one of the things that we know from some surveys we've done, in fact, remember back in week 1 I didn't quite finish the lecture and we were going to look at a survey done by one of our master's students a couple of years ago. One of the things that Sofian found with his survey of Australian data warehousing practice is that the ETL process is one of the most time-consuming, expensive parts of the data warehousing process. So if you're building an independent data mart and you're doing lots of duplication of the ETL process, you're duplicating the most expensive, hardest to do, most technically complex part of data warehousing, which is not necessarily a smart thing to do. But they work. They generally do work. The problems that arise tend to be the medium to long-term issues of integration, consistency of data, consistency of reporting, and consistency of support. Often what you'll find is that, the stories that the IT departments in organisations tell is that business units build their own data marts without letting the IT department know. They don't necessarily hire the best IT talent to build them. Often they'll build them themselves. And they kind of work and tick along, but as soon as something breaks, it's the IT department's fault that it broke. But they didn't build it, they didn't design it. How can they be... And yet they're responsible for making sure that it runs over time. So IT departments hate these kinds of systems because it's out of their control. They love enterprise data warehouses because A, they get big budgets to spend on big, long projects, so they can build these big systems to manage. But it also means that the control is centralised with the IT department. So the IT department can manage it, put in security and engineer in redundancy and reliability into the design, so that when the system does go down, okay, they're responsible for fixing it, but they know how to fix it because they've designed it. So the medium to long-term issues, like I said, are maintenance, data quality, data integration, data consistency, and so on. So a lot of data warehousing projects, in fact, kick off because organisations look at their data warehousing resources and find this kind of spaghetti mess of dependencies between decision support and source systems. And they go, well, we can't make sense of any of this. Let's scrap it all, consolidate them all into a single enterprise data warehouse. So often the answer to this is to do this. The downside, of course, is that doing this means that all of these systems no longer have the customised, tailored data management support that you get from these kinds of structures. It looks like a mess, but the individual users, the guys who use these systems, love them because they are tailored to their individual needs. So the user of this data mart here, maybe for the sake of the podcast I should use the mouse, so this data mart here can be customised for these groups of users, whereas this data mart here might have very different design requirements. But when you do this, it's kind of the big brush, one-size-fits-all kind of approach. A little bit of customisation possible through views, but you're sacrificing some of that customised support for more centralised control of the data. So these independent data marts, they work in the short term, they naturally, organically come about in organisations, but they do lead to all sorts of technical issues in the medium to long term. So what's the answer to these two sort of situations? On the one hand, we either have a big bang approach, not very good support, or this small scale messy approach that provides good support, but it's not necessarily very reliable. Possibly more. Possibly. The answer, my answer seems to be every week. It depends. Yeah, look, once you add up the overheads across everything, certainly the ETL side of things is much more expensive here because everyone's duplicating the effort. The scale's smaller. You tend to achieve quicker wins. You tend to get results out of this kind of approach quicker than with the enterprise scale approach. But I reckon if you added up all of the costs over the lifetime of an enterprise data warehouse versus this kind of approach, I'm not sure the costs would be any less, possibly more.
I think that's useful when you've got in multinationals, when you've got overseas as well.
Yeah.
Short companies, subsidiaries.
Yeah, well, exactly. This kind of thing happens naturally when you've got a multinational corporation. Each subsidiary tends to grow their own. But I've seen a lot of multinational projects that are all about building an enterprise data warehouse to solve this so that the global head office can actually get some reports. Because one of the consequences of this is that everyone at the national level is kind of supported, but no one at the global level knows what's going on because the reports don't filter through. So, yeah, well, that's right. There's attempts to integrate things, and you end up with either an enterprise data warehouse approach or what I'm about to show you now, what's known as a dependent data mart. So this is kind of the response to, I guess, a middle ground response. Instead of going the big broad brushed approach versus the small scale approach, we actually combine the two together. So the dependent data mart approach is a situation where we have customised data marts for smaller groups of users, but instead of each data mart having its own ETL process talking to the source systems, we build an enterprise data warehouse to handle the ETL process, and then the data marts source their data from the integrated data warehouse. So it looks a little bit like this. So enterprise data warehouse integrating the ETL process, and smaller scale data marts that customise support for the different users. But can anyone see the main problem with this? If we're trying to cut down cost and complexity. Well, you kind of, yes, along those lines. It's to do with redundancy. Not only are we actually doing this, but we're also doing this. So we've still got the complexity of these enterprise things, and we've still got to build a bunch of data marts on top of that to customise for the end users. So if we're sitting around for a long time waiting for the enterprise data warehouse to be built, we're spending time not supporting the end users with our data marts.
What do we call the process from the data warehouse to the data mart?
You could call them an ETL process, but they're a very simplified ETL process.
So you think maybe they can use the same tool?
Possibly, yeah. It depends on, what you might find is that each data mart is actually implemented on a different tool set, because depends on how centralised the control of the design of the warehouse of the approach is. But if each different business unit is building their own data mart, you might find that one business unit uses SQL Server because that's what they've got. So maybe the marketing department uses SQL Server, the accounting department might use something that's bolted onto, say, SAP or something like that. So you might find that the data sourcing tools, the marketing department uses the SQL Server data integrator tools. Maybe the accounting department uses whatever's built into SAP. But essentially it's trying to achieve the same aim as the ETL process. It's just that these, sorry, I should use the mouse. These versions of the ETL process are much, much simpler because you've already done all the integration and transformation, or a lot of the integration and transformation in the enterprise data warehouse.
Now you've only got the one sort of 2D flat file data warehouse that has sort of pre-formatted information. So you've got less flexibility for these independent uses of data marts.
That's right. Yeah. So as soon as you start, well, again, it depends. If you've designed the data warehouse appropriately, and what typically happens is the enterprise data warehouse is structured in a third normal form structure with transaction level granularity, so that the data marts can then aggregate as much as they like, and there's still that flexibility to come up with your star schemas as required. This is actually the approach. I'm not sure whether they officially advocate it now or not, but it's certainly what they do in practice, what Teradata actually do. So Teradata, large vendor of data warehousing, of large data warehouses, and if you look at their literature, they kind of talk about this kind of thing, but what they do in practice really is this kind of thing here. So you might have a Teradata data warehouse running the enterprise layer, third normal form, transaction level data, and then probably not a Teradata data mart. Possibly you might have a small scale Teradata data warehousing appliance for the data mart, but very often it'll be a almost virtual data mart built into the delivery system tool. So it might be, say, a business object universe or a Microsoft's OLAP cubes that store the data in the data mart. But this kind of approach, in theory, allows us to customise the data whilst maximising integration. But the big downside is the cost. We're doing both enterprise data warehouses and data marts as well. So there's a significant amount of duplication of effort. And to a certain extent, you're losing out on the benefits of the data mart approach and inheriting a lot of the complexity issues that you get from the enterprise data warehouse approach.
That's the structure of the lab.
Yeah, a lot of large organisations do this. And this is often the response, the actual response to this, whoops, wrong way, this kind of mess here. So you look at this mess and go, oh, how do we fix it? Oh, let's replace all the ETL processes for the data marts with a single enterprise ETL process and data warehouse, and then these data marts can source their data from the enterprise warehouse approach. It wasn't NAB, but one of the other large banks I know of had this kind of structure here. They wanted to build an enterprise, do a dependent data mart structure, but no one really understood how all this worked, and all of this had become mission critical stuff. So they were keeping it limping along, but they were just dreading something breaking because no one really knew how it all sort of fit together. So this kind of stuff can lead to real problems because you find you build a system and all of a sudden people start relying on it, and the people who originally designed the systems leave, and then you've got all these dependencies that no one really understands, and it was a real problem for them. They asked us, the DSS lab, to come in and do some consulting for them to try and sort it all out. We said, yep, you've got a problem there, and then backed out. We didn't want to. We would have been there for years if we were going to solve that problem. So I'm not sure what they've done now. I hope they fixed it. Okay, so
I was also going to say that needs a lot of support staff.
Yeah, each of those data marts requires people to run it, maintain it, look after it, keep it evolving, things like that. But given its smaller scale and the users are closer to the data warehouse, they're closer to the data because it's more kind of their system, there's more of a sense of ownership. So you tend to find people willing to sort of put their shoulder to the wheel, keep things going. The danger is that you build up a certain amount of expertise in a business unit and then people leave. Whereas an IT department, centralised IT department, there's more official structures around training and passing on of skill sets.
I think up the NAB, it's more centralised.
Yeah, yeah. I'd be amazed if it wasn't. It's yeah. Cool. So, because there's all sorts of security issues that banks need to maintain that lends itself to a centralised kind of approach. The problem, for those of you who are doing 5094 with David, in fact, we're going to look at one of David's case studies in this unit too. I think I've got to refresh my memory about the case studies we look at, but you certainly cover it in 5094. David did a data warehousing case study at a large insurance company, and their centralised approach actually killed the project. And they had a sort of subsequent Skunkworks type project that was very decentralised, and that one actually worked because the decision support requirements tend to be decentralised, whereas the tendency of IT departments to do this kind of thing is about centralisation and control. And there's a bit of a conflict there. And not really sure what the answer is, but yeah, there's certainly a tension. Anyway, we'll talk about governance later in the semester, and if you're doing 5094, you'll talk about it there too. Okay, so one of the responses to that cost and complexity issue of having to go ahead and build an enterprise data warehouse as well as the data marts is an approach that Ralph Kimball is a very big advocate of, and there's quite a few adherents, I guess, around the world who think that this is an ideal kind of approach, and on paper it looks fantastic, is to actually ditch the enterprise data warehouse layer but replace it with a kind of virtualised ETL process. So instead of having a physical database to store the data as it's being fed into the data marts, this approach treats the collection of data at the enterprise layer as a transitory kind of thing. So the data comes from the source systems, it's managed centrally by one single ETL process, but the data is not physically stored. It's shunted on to the data marts for physical storage. So you end up with a structure that looks a little bit like this. So replacing the physical enterprise data warehouse with what Kimball calls a data bus. Bus in the computer architecture sense of the term bus, where you've got data shunting around inside a computer. Different peripherals can take data off the bus or put data on the bus and shunts around the computer. Same kind of thing here. So each data mart can actually pick and choose from a kind of smorgasbord, if you like, of dimensions and fact tables and measures and things like that, and build its star schema. But there's one centralised ETL process that manages all of that. So each of the data marts synchronise their ETL process. Steve's turned up, that's excellent. There was just I reckon maybe a 5% level of panic in me just because I hadn't spoken to you today to see whether you were coming.
You just didn't sync.
Yeah, we are, yeah, that's right. So the data mart, the bus approach relies on a synchronised ETL process where each of the data marts have a consistent definition of attributes, so basically a consistent data dictionary across all the different data marts. And the data marts pick and choose which bits of data they need to support their end users. So it's essentially the same as the dependent data mart approach, but you don't have the expense and complexity of building an enterprise data warehouse and maintaining that. Instead, data gets stored temporarily, it becomes available to the data marts, they pick and choose, construct their star schemas, and then the data finally physically resides at the data mart layer. So the advantage of that, of course, is you don't have to worry about the expense of building an enterprise data warehouse. You're maximising the benefits of the kind of independent data mart approach. You've got all this data available to people if they want to develop another independent data mart. So you kind of get the same benefits of the independent data mart approach, but there's consistency across them. So there's sort of a centralised push, even though it's a decentralised level of support, there's a centralised push to have consistency of data standards across the organisation. The problem with this approach is that getting that level of consistency across the organisation is really, really hard. At least with the dependent data mart approach, you can sort of enforce that consistency by saying, well, here's physically the data we've got in the data warehouse. You can have anything you like from here. But because it's kind of virtual with this bus kind of approach, it's kind of a psychological thing with people. It's not quite as real as a dependent data mart structure. So getting that agreement on definitions in an organisation about data definitions, data formats and so on is really, really hard to do. I've sat in lots of different presentations from people whose job is just data dictionary construction. Their job is to come up with the data dictionary for the organisation, and it's a full-time career. It's just hard stuff. Steve, have you come across this kind of kind of thing?
Yeah, the problem with this is like the independent data mart, life tends to start as a little independent one here, and then we'll have another one over there. And then suddenly organisations, maybe 1 or 2 years down the track, have to actually put a big pause in their data warehouse process to go, okay, we've got all these independent tribes that either don't talk to each other or won't talk to each other, and there's like a big negotiation process that has to go on to actually sort of federate them.
That's right.
Because they need to think about doing that in the first place.
And everyone's become used to their definitions because their reports are structured around the assumptions that they've made, building it into the data mart. So as soon as you try to do this or this, you've got to, like Steve said, spend time negotiating, and the process can take years, literally. And everything kind of comes to a grinding halt as a result. So there's no perfect sort of technical architecture. These are kind of the archetypes. And there's lots of different sort of variations and mixing and matching of these different kinds of approaches. Sorry, I've gone a little bit too far. But the federated data mart approach depends very heavily on metadata, whereas the dependent data mart approach, you've got a physical database to kind of enforce it. It's Kimball's kind of personal favourite architecture that he advocates quite strongly with his consulting practice. But in terms of actually seeing it working on the ground, I haven't actually seen a successful federated data mart structure here in Australia. Steve, have you done any work on these?
A couple.
You tend to see these dependent structures a lot more.
They work best if that's your end in mind.
Mm.
If you start the process saying, well, yes, I'm going to build a data mart here, and I have a rough idea that there's going to be a couple of other data marts down the track that will be of different topic areas.
Mm.
If you know that, you can start to architect your ETL processes.
You used architect as a verb.
I checked the other day, it is actually...
Oh, no.
The OED says it's valid.
Well, I lost faith in the
That was
OED.
back actually to like 1867 or something, so they've been corrupting the language since back then.
Oh, well. I'll have to live with it then.
That's right, but then again, OMG and FYI are in there as well.
Exactly right,
So it doesn't
yeah.
say a
Lol.
lot. If you prepare for that, it's a lot easier to add them in and to create a federated or dependent structure.
Yeah.
If they're done separately by different people with their own different consultants brought in to do them and all that sort of stuff, very hard
Yep.
to bring them back together.
Yep. Okay, so that's the federated data mart approach. So the kind of 4 archetypes are the enterprise data warehouse approach, and then 3 variations of the data mart approach: independent data marts, dependent data marts where you've got an enterprise data warehouse, and this kind of federated or bus architecture. So that's kind of one of the major technical decisions that a data warehousing project team need to make. There's a few other physical design decisions that come into play as well. When I say a few, I mean there's actually a lot. One of the most valuable sets of skills you can have on a data warehousing project team, apart from a fundamental understanding of decision making in organisations and how to talk to managers and things like that, on the technical side is the skill set to run a really good database management system. So really good DBA is worth their weight in gold. And to a certain extent that depends very much on the toolset that you choose. One of the things that we're going to look at, I think next week actually, is how you go about choosing different toolsets. And to a certain extent it doesn't matter which toolset you choose, they all tend to talk to each other. Relational database management systems have been fairly standardised since the mid-1980s. So we've got lots of tools to integrate a relational database management system with other systems and delivery systems and so on. So whether you're using DB2 or Oracle or SQL Server doesn't really matter too much. Where it does matter is in the skill set that you've got to run that DBMS. So if you're an Oracle shop because your transaction processing systems run on Oracle, it wouldn't make much sense to actually run SQL Server because all of your skill base is in running and tweaking Oracle databases. So the real value of a good DBA comes in knowing which kinds of alterations to make to the configuration and settings of the DBMS and some of the structural patterns that you can use within the data schema itself to maximise the performance of that DBMS. And the kinds of things you do in SQL Server may be very different to the kinds of things you do in Oracle to kind of maximise that performance. But So the technology itself isn't too important as long as it matches the skill set that you've got in the organisation to run it.
Just one little caveat. Some transactional DBAs, transactional system DBAs, are absolutely the duck's guts at getting the transactional system humming.
Yep.
The way they have to approach getting a data warehouse or a database server humming is very, very different, and some of them get very fundamentalist in their
Ideological,
approach.
if you like. Yes.
Almost like, terrorist about,
Yep.
why
Thou shalt have boycott normal form. Or,
they'll want to snowflake your dimensions.
Yep.
And all those sort of things. So you've got to get someone that's a little bit flexible in their approach.
Or had some experience running a...
Understand the differences.
Yes, exactly. One of the first things you do, you'll be asked when you install a DBMS, if you've ever installed a DBMS, is how the database is going to be used. Are you designing for OLTP, or are you designing for OLAP or decision support? So right from the sort of installation phase, there's kind of pre-configuration that's going on to customise for the particular kind of usage patterns you're going to have. But as I hopefully convinced you back in week one, the design requirements and the usage patterns of a data warehouse are fundamentally different to transaction processing systems. And like Steve said, you have to be able to cope with the idea of those, of designing differently for those different usage patterns to get the most out of the physical aspects of the data warehouse. But the kinds of decisions that get made, and these are essentially the same decisions you make for a transaction processing system, but different choices that you actually select for each of these. So you'll need, very often you have to deal with standards, particularly if you're talking about a federated or even dependent data mart approach where there's got to be consistency across the organisation for definitions of terms and things like that. So there may be naming standards for tables and attributes and those kinds of things. But you also need to think very carefully about where you physically store the data, and the architecture that you select is going to play a big role in that. But even having made those sort of broad architecture decisions, you may find that you've got several servers, perhaps different user groups in different geographical locations, and how you physically split up and partition the data will directly influence the performance that you get. Ideally, you want data physically located close to the people who most frequently access that data. And to a certain extent, that requires monitoring usage of the data over time to see who's using what, so that you can then physically, maybe horizontally or vertically partition your tables and things like that to maximise performance. You also need to think carefully about the volume of data, and we're talking often terabytes worth of data, but keeping in mind that usage pattern with a data warehouse of a small number of database transactions, but each of those transactions tends to hit large amounts of the database. So particularly the fact tables tend to get scanned quite heavily. And the thing you want to avoid, any DBA will tell you, the last thing you want is a full table scan of any table in a database, particularly the fact table. That's the prime cause of slow database queries. So you need to think carefully about data volumes and the impact that doing things like pre-calculating aggregates, the kinds of indexes that you select on certain attributes and so on, all impact volume versus performance. And of course that's exactly the same for a transaction processing system, but the selections you make will be quite different for a warehouse. One of the characteristics of data warehouse data too, particularly if you're doing a star schema type structure, is this issue of data sparseness. A nicely normalised 5th normal form, or 10th normal form I think there is now, transaction processing system tends to be very compact. You store data once and only once. Null values are, optional attributes are kind of in the structure, but they tend to be minimised. Whereas with a star schema cube multidimensional structure, that's inherently a sparse structure from a logical perspective, because not every customer buys every product from every store at every time period in your data warehouse. So you have this logical data structure with lots of blank spaces in it. Now, ideally, those blank spaces don't get stored in the physical database, but you have to be intelligent in how you design the schema to ensure that you're minimising emptiness in the disk, because emptiness on the disk still takes up disk space. In some cases. Some DBMSs are smart enough not to store nulls on the disk, others not so much. You definitely don't want to be storing zeros.
It's got better.
Yeah.
But in the, God, far too many years for me to remember. There was,
Back in my day.
back when I was a boy, there was one of the OLAP servers called Holos came out. One of its greatest selling points was how efficiently it handles sparsity.
Mm.
You know, how effectively it stored nothing.
Yep.
And that was a huge breakthrough of the day because there was so much nothing being stored on very expensive hard drive back in the
Yeah.
day.
So you remember in the tutorials we did that calculation of the potential maximum size of a cube structure, and we ended up with petabytes of size for even a fairly small 4-dimension star schema. So unless the system's intelligent about how it stores things, and unless the DB designers are intelligent about how they structure things, that can be an issue.
A lot of the current database engines now, the relational ones, are implementing very good column-based compression.
Mm.
So, for example, if you've got a gender dimension and it's just got male and MF and male and female and all that sort of stuff, they all represent a common value back in the fact table. So it actually compresses repeated values is very, very effective for compression. So you can they get ridiculous compression rates sometimes, like 80-90% compression.
Yeah, because there might be only one of two possible values. Well, gender's not two possible values, I guess, but as it turns out,
It's a lot more.
it sure is. It was, in fact, it might have been you who told me this story. The attribute title for a person, the official number of possible titles was in the order of 20 or so for this organisation, but they had in the order of hundreds of different titles. Variation MR with a dot, MR without a dot.
My famous invention there was the gender title mismatch index. and this all happened because a very high value customer for this financial organisation seemed to get his knickers in a twist when he got a letter from this organisation saying, "Dear Mrs. John Smith."
Oops, yeah.
And for some reason he took it so personally that he decided to write a letter to the CEO complaining.
Did heads roll?
Hence the gender title mismatch correction project.
Keeps consultants busy. That's good. Yeah. So yeah, you have to think about all these things, and so it's not just the logical design, the database schema that you have to think very carefully about. It's the physical design and structure as well. And this sparseness issue follows not just in the physical design, but also the user interface as well. How the tools handle null values in things like drop-down lists and so on as you're using the reporting tools is also important. So sparseness is actually a pervasive kind of issue. Anyway, these other physical kinds of issues, they're kind of self-explanatory, but as I said, because of the fundamental different usage patterns you have with a warehouse compared to a transaction processing system, mean that you make often very significantly different choices for each of these kinds of decisions. Pod tells a great story. Peter O'Donnell, for those of you who don't know Pod, tells a great story about a data warehouse manager who was trying to improve the performance of his data warehouse, and things were ticking along okay for a while. And he was a friend of Pod's, and they were going to meet up at a conference in Sydney. They hadn't seen each other for a couple of years, and they got to Sydney, and it was great to meet you. I can't remember the guy's name, John or something like that. And he'd only just made it because he was trying to keep his data warehouse going. He was working with his team to try to make the whole thing more efficient. But he managed to get a couple of days away to go to Sydney. Just as the conference is about to start, he gets a phone call. He has to go out and take it, and tells Pod an hour later, I've got to go back to, he was in Hobart, got to go back to Hobart and fix our data warehouse because it's broken. He's trying to diagnose it on the phone, and before he catches his flight, he's talking to the people. And what was happening with the data warehouse was that the ETL process was failing after a couple of milliseconds, I think it was. We'll say a couple of seconds. The ETL process used to take in the order of several hours to run. So the ETL process would start up and then it would die. So they couldn't work out what was going wrong. There was no error message being flagged. It was just stopping after a couple of seconds. So this guy, John, booked his flight back to Hobart, hundreds of dollars to get a last-minute flight from Sydney. And just before he was about to leave, he said, just have a look at what data is actually getting into the data warehouse. Like, look at the data warehouse, and all the data is there. So the ETL process was actually working. What had happened before he left for Sydney was he changed a buffer setting in the DBMS from, I think it was a couple of kilobytes to a couple of megabytes or something. Just one number in the DBMS. And that reduced the ETL process from several hours to a couple of seconds. Might have been a couple of minutes, maybe I'm exaggerating a little bit. Never let facts get in the way of a good story. But it was just this kind of astounding improvement in the ETL process just by changing one number in the buffer settings of the DBMS. So this guy cancelled his ticket and stayed up in Sydney for the conference and came back a hero because he got the ETL process down from a couple of hours to a couple of minutes. Little things like that are just so hard to predict. There's no one who can tell you that the kinds of effects you might have from changing just one or two settings. There's so many interacting variables in the running of a DBMS that, to a certain extent, maintaining a database management system, and particularly a data warehouse, is about experimentation, trial and error, and see what happens. All while crossing your fingers that you don't break anything fundamentally. Anyway, buffer management, that's up there just because of Pod's story. Indexing, those of you who've done 9003, you should all know about B-tree indexes and bitmapped indexes and hash indexes and things like that, speeding up the queries for different kinds of data and so on. All of these things are things that a good DBA is going to be able to do for you. And as I said, the benefit is they're worth their weight in gold. They can significantly improve the performance of a data warehouse without the users actually noticing anything, except everything just sort of runs faster. Partitioning, you should all know about partitioning, and we're getting to the midpoint in the lecture. I'm going to hand over to Steve. So I won't talk too much about partitioning, but you all know about splitting tables up, horizontal and vertical partitioning. Can speed things up, reduce the amount of data that you have to scan through to run a query on, and the queries run faster.
Just one big benefit of partitioning in data warehouses is it reduces backup time.
Yep.
Because we know much of the data is non-volatile, so if the data from 5 years ago is locked away, if you petition on a yearly basis, you can just back up that data,
yes,
and then never have to back it up again. You get the backup because it's locked.
Yep. It also means you can have parallel backups as well. So if you're just physically splitting your database across multiple servers in different geographical locations, each of those locations can do their bit of the backup.
Backing up terabytes takes time.
It does. And we're talking petabytes now, not just terabytes. So yeah. Used to be we were talking about gigabytes and thinking, oh, gigabytes. I shut gigabytes around on my computer at home now. It's yeah. Okay, so indexes. Yeah, if you've done 9003, you've seen all of this material, so I won't bore you again. But here's a B-tree index in action, just to remind you of how it all sort of works. Yeah. So different indexes for different kinds of data can significantly improve performance. And finally, there's sort of not just the technical decisions, but sort of the operational governance, if you like, the policies that you put in place to keep the systems ticking over. You remember we did that project trying to come up with a data warehousing methodology. Didn't turn out so well. It was kind of a failed research project. But one of the big things that we got out of talking to a focus group of developers was that just the operation, the running of a data warehouse, is as much a part of the development process as the database design or the resourcing and planning and so on. It's a significant job to do. So coming up with policies to help manage the complexity of that process can improve the sort of the day-to-day operations of the warehouse. We're going to look at this topic of data warehouses as chaotic systems. In fact, that experience that Pod had with this guy at the conference in Sydney led him to do a bit of research or do a bit of thinking on the topic of chaos theory and running a data warehouse. But you need to have policies in place for things like who's responsible for data quality. Is it the people who run the source systems versus the people who run the data warehouse? Who pays for fixing up data quality? What happens when things go wrong? Who gets called? Who's responsible for fixing it? If the ETL process falls over at 3 o'clock in the morning, whose job is it to get it up and running again? Who gets woken up? Those kinds of things. But to a certain extent, there's a certain level of an art. It's an art form rather than a science to a certain extent, just because it's so complex. All right, it's 10:59. So, are there any questions that you guys have got about the technical architectures or the physical design decisions, those kinds of things?
I could visualize the Federation one, center field again. I'm familiar with the warehouse, not the,
Yep.
that virtual bus. But doesn't matter, I can read
No, that's right, there it is.
information.
Ah. So this one. So essentially, it's the same as the dependent data mart approach. It's just that instead of having a physical database there permanently storing the data, it's just data flows through here. Think of this like a smorgasbord. You know, you've got your buffet set up. Each of the different food items is a different, say, measure or dimension, and the data marts come along with their plate and say, oh, I'll have this fact and this measure, and here's my star schema, and that then gets physically stored. So the process runs, the data physically gets stored there, and this just waits until the next time the ETL process runs. Yeah.
Why shouldn't we represent it as like a whole ETL process?
Just largely because the work of extracting, transforming goes on here, and this represents the possible selections of things that these data marts here can select from. So you could, I guess, represent it a bit like this, but the message, the vibe of the diagram, the gist of the diagram, I guess, is that this stuff here is consolidated into a single ETL process. But not every data mart takes every piece of data from the ETL process.
And the other question is,
Yep.
when you're working
Como se dice?
the fragmentation or research,
Sparseness
Capacity.
or partitioning.
Competitioning.
no.
Yeah, let me find.
It's like when you divide the database into different parts.
Yeah, partitioning.
Partitioning.
Yeah.
Is it like table spaces?
Petitioning is where you actually have like one logical table,
It's like the seed,
but
right?
it's physically split over multiple hard drive spindles.
So you divide the same table.
Mm.
And you say, okay, all of the records that have a date from the 1st of January 2000 to the 31st of December 2000 live on, because it might be 2 terabytes of data, live on this physical disk, and then the next year lives on the next physical disk. And but
Those
also
disks
that
could
petition-
be-
And then you can lock it because, hey, you're not changing the
Yeah.
transactional records back from 2000, but you still need them available. So if they're locked off and never changed as read-only, you can back them up once. And then if your data warehouse server becomes a smouldering ruin, restoring, you don't have to regenerate that data. You can just get the backups and restore petition.
So the end
And you
user-
may have to just run the current year's worth
Yeah.
of data.
So the end user still sees a single logical table, and it's just physically they're stored in possibly separate hard disks, separate servers, possibly separate locations as well. Yeah. And you've got not just that's the horizontal partitioning. You can also vertically partition tables as well, so that only certain columns are available to certain or are stored in certain physical places. That's more of a transaction processing design choice.
So
though.
I've seen that for security, like
Oh, yeah,
security data warehousing.
Yeah. You can replicate a lot of that with views, though. Yeah.
Then sort of more different tables that develop instructions
Yeah.
instead of one code.
Yeah. That's right.
In the diagram independent data mart,
Yep.
each data mart you put in separate server or just one server?
Usually separate servers. Yeah. But
Because
there's-
they tend to spring up like mushrooms
Exactly.
independently.
so the way it kind of organically happens in an organisation, yeah, like mushrooms. It's a good analogy. Is a business unit or a group of users get together and go, well, look, we've got a bunch of reports we'd like to be able to run, or we'd like to do this kind of analysis on this bunch of data. We need to put that data somewhere so we can do the analysis on it. Someone says, oh, well, I've got a spare computer under my desk, got a copy of SQL Server, chuck it in there, and before you know it, it's become this mission critical physical database that needs to be maintained. So the data marts tend to proliferate, but there's a push now towards cloud computing or the use of ERP and perhaps creating custom tables within ERP systems and things like that, and that would be consistent with this kind of thing as well. This is I guess, a logical representation, not necessarily a physical, but often it is this physically this messy as well. Well,
That's assuming it's backed up.
you're assuming, yeah, exactly. So each of these things may have its own backup procedure in place. Some of them may not. Some may automatically be backed up because they're running on servers that are maintained by an IT department anyway, and it gets backed up.
But one of the implications of the independent data mart approach with backup is backups will, assuming they're done, will take longer because often the same data is stored in different data marts. So you've got duplication, triplication of elements of data, so the data backup will take more time.
And the sort of compression stuff Steve was talking about before, if you're working on separate tables, you're not getting the compression. Yeah, exactly. Okay, we should take a break then. It's 11:05, heading into Steve's time now. So go grab a quick coffee, come back, and Steve's going to talk to us about ETL. Do you want to audio record?
Yeah, I've got the iTalk online and a microphone.
Okay, cool. Well, actually, what I might do is I'll just leave this recording sit on the lectern and just sit there.
I can just plug in my microphone.
But what are you recording to?
I can plug in that. I have a Shure microphone.
Okay.
See, magic.
I might stop this recording then and start the recording again.
Thanks.
Steven.
Steve-o, mate.
Steven. I'm Roberto.
Robbo. Felixo. Stop. 3G. Indeed. In the meantime, I'll save this.
Coffee. Play a house.
Yeah. What are we doing? 505 podcast. Folder. Episode 7. Good thing it's on the screen.
I read your proposal.
Yes, and?
I think.
Does he accept?
Yeah, I accept your proposal. Which kind of proposal? The thing is, I think you need a reference to this.
I think my referencing wrong.
No.
Oh,
You need a citation.
did I miss
You need
something?
to, yeah, no, you need an evidence of what you're saying. Probably you need some reference.
What do you mean?
You have a state,
Yeah,
but it's just, I don't know where that thing came from.
I made that up.
Remington, 2011.
Yeah.
Brain.
11.
Personal correspondence.
Hey.
So, Brain, what do you think? Steve,
Recording of conversation between one of my many multiple personalities.
No, you're saying something about the
Something about.
industry.
Okay.
Oh, is that the bit where I had correspondence with people in the? It was pretty much. Yeah, I went to conferences and everyone said that. So what am I going to say? How do you sort of quote that? I'm not quite sure.
Be gentle.
assuming this is going to. Yeah, might be something. Oh.
No microphone available. 3G.
Yeah.
It actually picks up really well without the...
I'll do it on mine because with the iTalk thing it works.
Okay, yep.
And it syncs off really quickly anyway, so.
Take the computer, sit up the back.
And heckle.
Yeah. I don't know, Brad's Facebook. This is what everyone else does. All good?
Yeah, just closing down all the things that are going to pop up and
Look at your... Holy crap.
I'm a steampunk kind of guy.
Yeah.
Actually, the other one's better. This is post-apocalyptic, looking out over the landscape.
Alright.
You're live. What?
Is VI a process or a system? Is VI a process or a system? You should say that.
I do say.
It's there, but
Okay. Yeah, I can see how that could be interpreted as not being quite
because they
there.
got the same problem.
Yeah. No, I can see that. Yep. All right. Hey? Mate, you can have the most elegant, you can have the most user management support, you can have the best data model in the world, you get this bit wrong, no, it ain't going to happen. See, I'm sticking up to the little arrow in the middle of the diagram that's always underrepresented. Okay. What I'd like you to do is strap yourselves in, because we're going to cover off in like 45, 50 minutes what is often in 2 or 3 days worth of course. So this is going to be a sort of 10,000 feet sort of overview of the important things about the ETL process that happens in data warehouse. I've actually been pushing, unfortunately, budgetary constraints are such that I would really love to have a whole data management unit to add to our suite of business intelligence, where we talk about ETL, we talk about master data management, we talk about enterprise data integration and all those sort of things. Unfortunately, the money didn't stretch that far. Had support from David Arnott for it, but yeah, politically we couldn't get it up and running. So maybe sometime in the future. Okay, so what are we going to talk about today? We're going to talk about a bit of an introduction to data integration. What is ETL and why does it matter? The ETL planning and design process, the data flow process, and very briefly at the end I'm just going to flash up a couple of slides about how you actually document the ETL process. For something that is so important, the ETL process that is, there's very little actual research done on it. There's a group of researchers in an obscure university in Greece that are actually doing some interesting work on this, but that's about it. Maybe there's something for me to do my PhD on. What I like to call the EIO of data integration, there's all these acronyms that you'll hear. There's ETL, there's ELT, which is not a typo. There's EII, there's ETLTL, and all this sort of stuff. So what does that all mean? Obviously, there is extract, transform, load, which is the one that's most commonly used. That is, data is extracted out of the source systems, some transformations happen to it, and then it is loaded into the destination or target system. ELT, as I said, not a typo. It is actually extract, load, transform. And this is where the data is extracted out of the source system. It is directly loaded into the target system, and then the transformations occur on the target system in the actual database engine. This is quite often done in databases that are more designed for data warehousing type approaches. So they have an SQL command set that's a lot richer than the generic command set. So standard transformation type things can occur within SQL. It's great if the database server that you're using supports that functionality, but it can actually limit the scope of things that you can do in the data warehousing approach. The other one, this is one of these things that looked really cool on paper. Demo's really good in the perfect world of perfect data, unicorns, and no child living in poverty. But I don't think the reality ever caught on. Enterprise Information Integration, or EII, it's about like a virtual integration of data, or creating virtual data warehouses or data marts. Every time I've looked at it, I'm going, this is really good, but it only ever works with perfect demo data. If you've got any sort of data that vaguely requires cleansing, error correction, standardization across multiple systems, EII becomes really, really complicated. The only time I could think it would work is if you had, sitting over the top of your enterprise information integration, a master data management, a really active master data management system that ensured that errors were virtually non-existent in your data. Do you talk much about master data management, Rob? I won't tell them, because that'll give them the incentive to want the extra unit on master data management. Pardon? Oh, you could discuss it in essay topics, yes. And then the final one is ELTL. Actually, it should be ELTL. Extract, load, transform, and then load again back off into other systems. I think this was just there was a really drunken party between ETL and ELT, and it all just went horribly wrong, and they've got to live with the consequences for the rest of their lives. So you'll see all of these acronyms. As I said, they're not typos. The unusual ones tend to be more like opportunities from software vendors to try and differentiate them, come up with an excuse to differentiate themselves from the rest of the pack. But the one that's most commonly used for all practical purposes is ETL. So what, in more detail, is ETL? So, firstly, ETL is not just for data warehouses. You can extract data from somewhere, any operational source, archive system, whatever. You transform that data, which, as I said, is cleaning, filtering, validating, applying business rules, or as I like to say, bashing it with a hammer and bashing it into shape, and then loading that transformed data into a target. As I said, it's not just about data warehouse. It's one of the last big projects I worked on before I left the real world and come here. We actually did it. I designed an ETL system which extracted data out of a source system, did transformations onto it, and loaded it back into itself. Now, this was a major data cleansing and validation exercise, but all of and it was a one-off thing, but everything that we did in the design and architecture of this system was exactly the same as if we were doing it for a data warehouse, other than there was some operational robustness that wasn't quite required because we were only doing it once. But we were talking about over 1 million address records and 400,000 customer name records that had to be cleansed. So why is it important? Well, I told you it's the most important part about data warehousing. The design, development, maintenance, ETL, can be as much as 70% of, and sometimes more, of the project time and cost budget in a data warehouse. If you're doing your costings and estimations for a data warehousing project and you don't come up with a really big fat number as the percentage of time for your data warehouse, double check your numbers. Sorry, it's the ETL component, double check your numbers. This stuff takes time, and it will even if you come up with a big fat number, it will always take longer than that big fat number. It's just one of those things, so factor that into your planning. The software to do this stuff is huge. It's like 1.34, it's probably $1.5 billion a year of stuff is sold. The really high-end stuff is outrageously expensive. Be prepared to sign over the life of a firstborn child to pay for it. It's just ridiculously expensive. And as we'll see with some of the other vendors that are coming up, obviously too expensive. We'll see with some of the other vendors coming up, some of these cost things are being dealt with. And this market is growing hugely. According to Gartner, the knowers of all things IT, or as I heard the other day, the makers up of all things IT, we're talking about 10% market growth per year over the next 5 years for the ETLs. So this is more to do with this whole push in industry in general for business intelligence and data warehousing just becoming more important and a higher priority for CIOs. If data warehousing and business intelligence is more important, ETL by definition is also more important. But there's also this issue of integrating systems together as well, where ETL comes in. So, the evolution of ETL tools. Back in the primordial days, I was thinking about this. Man has been doing data integration and sort of data transformation since time immemorial. We get a message and we transfer it into Morse code dots and dashes, and then it gets transformed back to the other end. So we've been doing this. The whole thing at Marathon was a data movement exercise. It was a message transformation. It was just a really long one. So we've been doing this for ages. But when we got into doing it with computers, quite often in organisations, when they decided to say, well, geez, this whole transactional system is not cutting it anymore, we have to have some sort of separate system to do reporting or analysis. Quite often, what was only available to them was scripts, a scripting language of some sort. Back in the early days, for those that are old enough to remember, the stuff was written in COBOL. It actually hard-coded in, written in C, Perl, PLSQL from Oracle and the like. Over time, this sort of hard-coded scripts tended to sort of morph into some standardised frameworks, and this was often by virtue of the fact that there were consulting companies involved, and they thought, geez, we could make more money if we wrote some standardised scripts and then made the client think that we were hard-coding custom code for them. So there was some frameworks got developed, so basically we've got reusable scripts. But interestingly, on the hard-coded scripts and frameworks, still 40-odd% of the world is using hard-coded and custom scripts for their data warehousing. I think that has a lot to do with the fact there's a hell of a lot of paid by the hour consultants working on data warehousing. And they justify their time by writing custom scripts. But I just couldn't be bothered doing it for reasons we'll look at in a minute. But sort of the next generation that came along was what's called code generators, where basically you use some sort of graphical user interface, and we'll have a look in a minute, where you put in define the data flow, and then you press a go button, and magically under the covers, it generates script, code, whatever. You might write it in Java or PLSQL or something like that. Oracle's Warehouse Builder is probably one of the most commonly used code generator type ETL machines out there at the moment. The sort of the most common and latest generation is pretty much what's called a data integration engine. I'm going back one step. The problem with code generators, again, is quite limited to a particular environment. Works really well if everything's Oracle, works really well if everything's a particular type of database, but if you're starting to get disparate database systems, it can be a problem. Data integration engines is the sort of the top end of all of this at the moment, where you have a purpose-built engine that sits purely and simply there to take data in one end, machine, munch it around in the middle, and spit it out the other end. It's a lot more flexible because you can have a lot more, at each end you can have different data connectors. You can apply, if you've got your data connectors set up, if for example your source system is currently Oracle and then you make a change to your source system and decide to go to DB2, quite often it's just a matter of changing the data connector on one end. All of the transformation logic, all of the business rules is written in a standard generic rule set and nothing has to change. So the data integration engines are, and we've got sort of both ends of the spectrum of expense there as examples. We've got Kettle, which is the data integration engine from Pentaho, and we're actually going to play with that in today's tutorial. And it's open source and can be free if you want to use it. And then we've got the other end of the spectrum, which is Informatica. And they're really feeling the pinch at the moment. Of course, tools like Kettle and the open source code generator tool called Talend are really cutting their lunch at the moment. It's this Informatica, if you get a full Informatica implementation, you don't think about turning this thing on for less than $200,000. And it can be a lot more than that. Kettle, you can download and install and be up and running. So given that you can download very good now, open source, I just don't know why people do hand coding, as again, other than just justifying hourly bills.
On the wiki, we spent 4 hours debugging the tutorial for Kettle.
They did change the version though.
It was a bug that's come across version, so it was bugging version first, but also
Yeah, there is that. But the source is there. One of the interesting things that Kettle is doing now is, I think they're calling it the KKF, which is the Kettle Kitchen Framework or something. Basically, when you're developing ETL, there's a lot of standard processes that you implement. So there's logging, there's reconciliation processes, there's transaction trapping, all of these standard sort of functionality. What the open source project Kettle's doing is actually developing standard blocks of data flow which apply to just about any ETL process. So again, you can say, all right, I need to implement a reconciliation process. Blob, done, rather than starting from scratch all the time. So they're trying to standardise a lot of this process. And then the final sort of, up and coming one is what's called model-driven architecture. this is where you start to your actual. It's a bit of this design becomes the code type of scenario. So if you start modelling your ETL process using some sort of modelling language like UML, which we'll briefly look at the end, the whole ETL package is actually built and designed in a model. You don't even need, one of the big downfalls of the other processes, you need a source database and you need a target database, preferably with some data in it, to actually build these. With the model-driven approach, you can kind of just do it all virtually in a modelling language and then spit it out to an engine. Beg your pardon?
You also create two databases.
Yes, you need somewhere either a temporary test version or the real thing. For all of those other versions, you need something to connect as a source and something to connect as a target. At least once. Some of the tools allow you to disconnect from the data sources once you've actually got a mapping, but some of them won't let you do that. So you can't sit on the beach with the internet turned off and do your development at times. So just here's a list of some of the common vendors. There's WebSphere DataSpage, Informatica, Warehouse Builder, SAS, Data Integration, Business Objects, Data Integrator. Probably the most commonly used ones now that the mere mortals can afford is the Microsoft SQL Server Integration Services, primarily because if you buy SQL Server, it comes free. And it is so functional and so affordable that many Oracle database shops will specifically set up an SQL Server box purely and simply to use the Integration Services engine to move data from one Oracle database server to another. It's sort of this closet heresy. They try not to, they go, this is not very good, I won't use this, but this is really good and affordable. And then we've got at the end, we've got Pentaho Data Integration, which is Kettle, and then Talend. So this is one of the reasons why tools like Pentaho or SQL Server Integration Services, Informatica and the like are so useful above just generating code, is that it's self-document. The process is self-documenting. You start at the start where you've got the little arrow, and then you get some dates, and we've had a successful end of day. Yes, go off. It's all the logic and the data flow is, and the metadata relating to the transformations is encoded in the actual process. If you're writing scripts and raw code and all that sort of stuff, most programmers tend not to write that metadata into their process, and even if it is, it's hard to get at. Most often, I think Kettle is and Talend is, most of these data flow maps are stored as an XML file. Therefore, they can be interrogated by other tools and the metadata are extracted out of them. And also, too, it reduces the cost of development because a business person that's got a bit of nous about databases and spreadsheets and the like can actually just do drag and drop type things, fill in some parameters, maybe have to do a tiny little bit of scripting, but if they're pretty good at Excel, they usually have that level of knowledge to do a bit of scripting. So you don't have to get a custom developer in to actually do a lot of this work. So it's quite good in that respect. This particular one here is actually used by one of the big users of Kettle is the Mozilla Foundation. They suck in all of the data logs from all of the web servers that track the downloads of add-ons for Firefox and all that sort of stuff to try and do all the analysis of who's downloading Firefox and what add-ons are being downloaded and all that sort of stuff. If you're going to buy any books, there's only two that are really worthwhile buying. The Data Warehouse ETL Toolkit is pretty much the generic Bible of ETL. It only came out a few years ago, and until then there was nothing. And it was written by Ralph Kimball. I think he wrote maybe a sentence or two in it. But he's put his name in bold, but that's Ralph. Not that he's not smart, but he knows how to brand things and ensure it's sale. But it is a really, really good generic book about the ETL process and how to implement it. The next best available book is probably the Pentaho Kettle Solutions. It's based on a similar architecture and approach to the Data Warehouse ETL Toolkit book, but it looks more specifically about implementing things in the Pentaho Kettle tool. So if you want to actually, for no cost, download something and practice on things and get used to the generic concepts, buying that book is quite good. And it's really well written about some of the underlying principles that it's based on are actually quite sound. The guys that have written it, they're not just sort of touting the product, the actual principles that they're underlying the book with are quite sound. Okay, there's two, and this is sort of the general approach that the ETL Toolkit book takes. There's sort of two lines that you follow when you're building an ETL process. There's sort of what's called the planning and design process, and all good things have 3 or 4 boxes and arrows between them. So some of the things you need to talk about. You start off with what's called the requirements and the realities. And this all sinks into the requirements gathering and the business needs and the justification of your data warehouse project. You need to talk about what are the business needs, what are the compliance requirements, because some of those, with the Sarbanes-Oxley rules in the United States, if you do any sort of data transformation and manipulate data along the way, you have to keep quite detailed logs of how that data was manipulated. So if your company goes and does an Enron and collapses in a screaming heap, the regulators want to know how did you get to those numbers? That report says you had made a profit, but actually you've just gone broke. How did all that happen? You need to keep logs of all those sort of things. So what are those requirements? Data profiling, how good a quality is the data we've got? Security, latency, how quickly do we need the data refreshed? Is it every 5 minutes? Is it every 7 days? Is it every month? Whatever it happens to be. An interesting one that can really trip you up is legacy licenses. What licenses for drivers do you need to get access into your source systems? And Oracle's a classic for doing this. They use this concept of indirect licensing, where, you've got people that are accessing the data from this system via an ETL system. Well, we treat that as a direct user on our system. Do you have enough licenses for that? Microsoft does a similar thing as well. They work on the theory, what would happen if you turned this server off? Could the system work? And if the answer is no, you need a license. You need an end user licenses for it. So you've got to be careful about what the it's bastardry basically on the part of the vendors, but they can trip you over with it. The architecture, as I said, hard coded versus an ETL vendor tool. Are we doing batch ETL loads? So every night we go through and load the data warehouse, or are we doing streaming? Now, streaming can be done for 2 reasons. Firstly, there may be a latency issue where, hey, we want the data to be no more than 5 minutes behind real time, so you do streaming. But some of the data volumes that are getting processed now are so large that it is impossible to process them in the batch window, maybe the 5-hour batch window that's available at night. So you actually have to do a little mini dump, a mini ETL process every hour. Not because you need the data that frequently, it's just you don't have enough hours at the end of the day to process the data. So you need to think about those sort of things. The other big one's horizontal versus vertical task dependency. That means, do we do one system at a time? Do we do the sales system, then we do the purchasing system, then we do the general ledger system separately, and then bring them together in the target? Or can we do parts of the systems together? And this is depending on how your integration. It's still on. That's the main thing. There we go. Back again. Exception handling. How do you handle data quality issues? if you've got rules saying that the gender can only be male, female or other, what happens if some other fourth value comes through? What do? Do you stop the process? Do you just flag those records and quarantine them and tell someone that they're wrong? How do you manage that? What happens if someone pulls the cable out of the back of the network cable out of the back of the source database? You're thinking, oh, that'll never happen. Been there, done that. Someone decided that they wanted to unplug the database server in the middle of an extract. What do? Your system has to cope with that. Or you will, the more of these how to handle recovery and restart issues, the less phone calls you're going to get at 3 o'clock in the morning. Or the amount of time you're going to be spending dealing with that phone call at 3 o'clock in the morning will be much less. Tracking metadata and security. How are we going to implement this? What hardware are we going to run the ETL engine on? What software are we going to use? That gets back to our hard-coded versus ETL tool. What coding practices are we going to use? Even if you've got 10 different developers and you've got that data flow type diagram I showed you previously, you need to develop some sort of standards about how each node in the system is going to be used. If you are going to record metadata in them, what's the structure of that metadata going to be? If you're going to keep notes, what type of notes are you going to add? And all of these there needs to be some standardisation in there so that if you are going to extract the metadata from some sort of third-party tool, it'll all come out consistently. Again, how is it going to be documented? How are you going to document this process so that, if you all get hit by a bus, someone else can come along and continue on the work? And again, quality checking. How are you going to ensure that the transformation process that you've built will actually do the job that it's supposed to do? Because this is the place in your data warehouse where it can all go horribly wrong from a data validation perspective. And it doesn't take much in an environment where a certain number of powerful users in the organisation are hostile to the data warehouse being implemented for the tiniest single record error for someone to go, look, see, that bazillion-dollar total is missing one $5 transaction, therefore the entire data warehouse must be rubbish and we should scrap it. I told you we shouldn't have spent the money on this project. Don't worry, I've had, well, maybe the bazillion dollar was a bit of an exaggeration, but I've had the scenarios where something's been out by 5 cents, which turned out to be some sort of accumulated rounding error, and there was this whole bun fight that occurred over it. So the more testing you do in your ETL process to ensure that everything that goes through the process is correct, the less chance you've got of errors happening at the other end. And that gets us to testing and release. What development environments are you going to have? What test environments are you going to have? What production environments are you going to have? How are you going to hand off between the various layers? A lot of this is very similar to normal application development processes. The only problem is, particularly testing, you get an issue of how do you do volume testing? In that, if you're pumping through terabytes of data in your production system, do you have to set up like a duplicate, equally powered test environment to do the volume testing to ensure that it's going to process the data within the allocated 3 hours that you've got? Everything just becomes that order of magnitude more complicated in a data warehouse environment, primarily because you're dealing with just huge volumes of data. If you're doing a bit of testing for a transactional system, you process a few invoices, or you process a few purchase orders or something, or a customer inquiry lookup. The transactions take seconds. You can test a few hundred of them and go, yep, they all work and they all happen quickly. If you've got an ETL process that, even as efficiently as it possibly could be written, still takes 3 hours, where do you test that? When do you test that? So these are the things you need to think, because you might try it on your laptop as you're developing it and you've got 10 input records that goes into 10 output records and you go, sweet, it works, not a problem, it just runs so quick. All right, let's give it a shot now with 500,000 records. How long is it going to take? Because, and this is where efficiency in coding can bite you, or inefficiency in coding can bite you. If you have a routine that takes, say 1/10 of a second longer than it should, it's slightly inefficient. 1/10 of a second times 1,000,000 is a long time. So you have to think about those efficiencies because, again, everything's, it's just in bulk scale that you're doing things. How do you propagate updates? System snapshotting and rollbacks and performance tunes. With the system snapshotting and rollbacks, making sure that you take a snapshot backup of the system before you start doing your ETL load. Of course, it's really embarrassing when your ETL process fails and last night's sales figures are not available. It's a whole new level of embarrassment if the entire data warehouse is offline as a result of what failed. The business can usually cope with the fact that yesterday's figures are not there, but everything else is available. They get very, very narky when the entire system is offline. So it's much better to have a backup and go, oops, it broke, I'll just leave it how I found it, rather than, oops, it's broken, I wonder what happened there. I didn't touch it, Dolly did it. So this is where now we're talking about the data flow. And standard diagram, but in this case I've given the ETL process the prominence that it deserves rather than this single tiddly little arrow that it normally gets in most of the diagrams. You can see we've got the extract process, the clean and the conform processes, which forms the T and transform, and then we've got the deliver or the load process where it goes out to the applications. As you can see, each phase tends to have its own handoff data staging area, and we'll go into the reasons for that in a minute. And sitting over the top of it is a whole bunch of just common operations and control. So the extract process, as I said, it's just sucking the data out of the source system. Usually the best approach for this is get in, get it out, and leave. You don't want to do any processing, you want to do the minimal amount of filtering, because those systems usually have limited windows that they're available, and anything you do other than the select star from where yesterday's date will take a lot of time. Also, quite often in your ETL process, when you're doing your cleansing and your conforming, you might want to access that data multiple times. So the last thing you want to do back in your source system is, hey, I'll go and get yesterday's sales transactions, do something with it, and then come back again half an hour later and say, hey, can I get the yesterday's sales transactions again? I need to do some more work on them. It's much better to just grab one copy of them and then put them in the staging area and then deal with them multiple times. One of the other things that's often the trickiest thing to do with extraction of data for data warehousing purposes is what's called, I've got here, capturing change data, or what's known as change data capture. How do you know which records you need to extract? You don't want to have to extract every single record in the system every time, because a lot of times that's impossible from a time perspective. So you need to know which records in the last, so if you're doing it daily, which records in the last 24 hours were newly created, which ones were changed or updated in some way, and which ones have been deleted. So you have to develop a way to do that. And this is where I found is the dirty little secrets of programmers and application vendors are discovered. I have a number of software vendors that will be the first up against the wall when the revolution comes, and they will die painful deaths. They should never ever be allowed in front of a computer because they have done the most horrible things on their transaction systems imaginable. There was one particular vendor of a very large health management system who decided that we know much better than database management vendors about how to do transaction handling and record updating. They're all idiots. They don't know anything about that at all. We're going to write our own transaction handling system. Well, when we started to do the change data capture to extract which patient records changed in the last 24 hours, we worked out how crap their attempt at writing their own transaction management system was. As the system stood, it was impossible for us to identify reliably which records had changed. Some records, even though it was changed once, it was indicated that it had been changed 5 times. Some records that had been changed had no indication at all that they'd been changed. And all of these sort of things. So we actually had to go into the source system, or the source database, and write triggers. People familiar with triggers? Did they cover off triggers, Rob, in 9003?
There was at least a dot point on
There was a dot point? A trigger is a very small lump of code which gets ran when a particular database action occurs. So when a record is updated, for example, this little trigger will run and do something. Now, in our case, what we did when a record was updated, we had a trigger that said, go and write a record in a separate table that said this record was updated. Or go and write a record in a separate table that this record was deleted. Go and write a record in this separate table that a new record was created, whatever it was. And that was the only way. We had to sort of retrofit something over the top of it. That was the only way we could identify what records we had to change, or we'd have to extract every single patient transaction record out of the system every night, and we just didn't have the window to do it. So there's many, many different ways to do it. If this particular software vendor had just let the database engine deal with it, it would have been so much easier, but they didn't. Cleaning. As much as we'd like to think that, because all of the people that have been going to graduate out of here, that have done Rob's 9003, done all this sort of stuff, they're going to know about using data validation properly when they're storing data in databases. They're going to ensure referential integrity. All of your systems are going to be fine, but everyone else's systems are usually rubbish. You'll be amazed what people want to store in certain fields in databases. And the old, geez, we need to store an extra value in the database, but geez, it'd be really hard to actually add an extra column to this database. This field's not used often, so we'll store this other value in this column. And in this particular scenario, again, I'm not making this up, this is true. This particular large financial institution, who will remain nameless to protect their own stupidity, decided that the column in their investment system that was used for one-off bulk investments made by a client, so a client may retire, get $200,000 as part of a retirement benefit, invest that lump sum of money, was stored in a particular column. But not many of the clients did that. They then needed to add something in the database about people who made monthly contributions to their plan. And they sort of worked out, well, most of the time, the people that make the monthly contributions are not the people that make the bulk contributions. So they went, why bother adding an extra column in the database to do that? We'll just use these spare fields in the database. So the really funky cleansing and extract that we had to do there to work out, go back and go, okay, there's a value in this database that says it's $10,000. How do we know that that's a monthly, regular monthly contribution made by this client, or a one-off lump sum contribution made by this client? I think the term that was used, it's called column stacking. So it's like, hey, why have a column do one thing when you could do 2 or 3? So all of this stuff happens in databases. As I said, Mrs. and Mrs. and all that sort of stuff can be all over the place. Also, enforcing business rules. One of the examples that's given, if a customer in a frequent flyer program is a platinum frequent flyer, are they legitimately, do they meet the rules to be a platinum frequent flyer? You know, have they flown a certain number of flights in the last 12 months? Something like that. And again, we try to take the clean data, we stage it off into a cleaned data. Again, this staging off, you might go, why do we keep staging it off? This is all part about the retry, restart and rollback. You try and make sure that if something does fail and you have to restart, you make it possible to restart at the nearest most complete action in the process. You don't want to, if you can avoid it, go all the way back to the beginning, because it takes time. The conforming part of the ETL process, this is where the integrated aspect of a data warehouse being, one of the things that's integrated, this is where it starts to happen. If you've got more than one data source coming in, you start conforming your data here. How do you know that Mr. John Smith is the same as Mr. J. Smith? And Vanji, there's voices coming from your bag. No. Hello.
Sorry.
Where you start conforming data, the concept of householding. So particularly if you've got, many of your students, you're sharing houses. You're not married, you're not brothers and sisters, you're not family, but you're living in the same household. Some organisations want to know all of the people that are living in the same household. How do they know that? How do you blend that data together? This all happens in the conform process. The deliver. This is where we start pumping it into the source system. Now this is not just where we go, okay, we're finished with the data, split, dump it into the final system. Usually there's data already in the final system, but then again we've got the lazy ETL designers who go, this whole incremental update thing, that's just really hard. So the very first step or the very last step before loading is often drop database, recreate tables, and then load everything from scratch. That's really lazy. So when you're actually loading the data into the final system, you have to say, I'm putting new records into the dimension tables. What slowly changing dimension strategy have I used? Am I overriding the existing value? Am I only keeping 1 or 2 values? So which one do I need to keep? Am I adding one? Do I need to delete one? Or am I keeping full history? So I have to close off the current value and add a new value and make that the current value. Adding new values into fact tables. The really funky one is handling late arriving dimensions and facts. Earlier in your clean process, you flagged a whole bunch of transaction records that didn't meet the quality requirements for your system. So you dropped them off in a quarantine bucket and sent them back to their owners and said, fix them, they're broken. During the day, the transaction processing business has gone in and went, oh yes, the 74th of the 23rd, 3,267 is really not actually a valid date, even though I'm allowed to put it in. Again, true story. They've gone and corrected the date. The record has then come through back into the system, but it was part of the day before's transactions, not today's transactions. How do you make sure that that goes into the system the right way and in the right context? And really weird things, if you've had aggregations put into the system, you want to do some daily aggregation totals, you have to regenerate the daily aggregation totals because you've got new records from the day before in there. So this is not, as I said, it's not just a matter of spurting the data into the database. It's got to be done with a little bit of logic and a bit of care. And then finally, sitting over the top of it, as we said, was the operations process. And this is where we do the actual scheduling of the tasks. When do these particular tasks run? Are they a one every hour task that runs? Are they every 5 minutes? Are they once a week? Are they once a day? Do they happen on an ad hoc basis? Do they happen only when certain conditions are met? How does that all work? As I said, job scheduling, job execution, I should say. Exception handling. Again, what happens when it breaks? How do we log all of this? Recovery and restart we've spoken about. How do we make sure it, the minimum downtime if something goes wrong? And as Rob said, I still think there is a lot to be said about these data warehouses are chaotic. It's amazing how, the butterfly flaps its wings in Brazil, causes a tornado in Japan, a hurricane in Japan, sort of thing, typhoon in Japan. The tiniest little error in a source system can just cascade through your data warehouse and just create havoc. How do you handle that? Quality checking, and the most important is this reconciliation and logging. You want to log as much as you possibly can.